Alrighty, my friends, today we're going to be going over the specifics of y equals mx plus b. We're going to find m and b because that is the end goal of y equals mx plus b. What we did in the previous lesson was identify when a linear equation is given to us, and not just that, how to convert that into the y equals mx plus b format, aka slope-intercept form. Alright, so please go and master that first before we continue on, if you haven't already, obviously. But now that we're here, if you've already done that, now comes the point of all that, is to master how to find the m and the b of a line. So here's the thing that I don't think I really explained well in the last video. What is y equals mx plus b? I did explain that when we're dealing with graphs with lines, any line that's given has a slope-intercept name to it. It has its own little equation. It has its own little linear equation, and we must master how to find it, right? And like I said a million times, all you really need to do to find that is find the slope, aka the m of that line, and find the y-intercept, aka the b of that line. Once you find those, you could write out its y equals mx plus b linear equation. So that is what we're going to be doing today. We're going to be determining how to find the m and the b. I already said it. M is slope and the b is the y-intercept. But there's two ways to find the slope and the y-intercept. To find the slope and the y-intercept, you could find it visually, which is what we're doing today, or mathematically, which we'll be doing in the next lesson. Mathematically. Okay? So we are going to find the slope and the y-intercept visually today. So let's do that. First things first is the slope, aka m. When we're given a line on the GED test, we're going to be given a graph like this, and we're going to be told potentially to find the linear equation. Your brain should immediately say, I got to find the y equals mx plus b of this line, right? If you're lucky, if you win the lottery, they'll just ask for the slope, or they'll just ask for the y-intercept, because either way, the reason why I say you win the lottery there is because that's an easier answer, because you're just doing half of the work at that point, right? But I'll explain that in a second. The slope, my friends, all it is the steepness of your line. So as we can see here, there is a steepness to it, and every line, if they were to put a different line, has a different grade to it, right? And that's all slope is. So we got to find the slope of this line. How do we do that? There is 3 steps you need to do. Here I go with my steps again. But there are 3 steps you need to do in order to find the slope of a graph visually. All right. The way we do that is, first things first, step 1, locate 2 points. What I mean by that is this. We already went over the coordinate plane lesson 2 lessons ago, I believe. And it was your plotting and reading points. You got to be a master at that, right? To us taking the GED, a point is only a point when it hits your crosshairs of your grid. All of this right here are points. Just pretend I filled up this whole graph, and in every crosshair, in every cross of your literal grid, of your grid paper, your graph paper, that's a point for us, right? The mathematical textbooks, math geniuses, they'll tell you, well, there's an infinite amount of points here. Literally all of this is a point, right? Everywhere you could see is a point on the graph, right? It's just a matter of finding the number of it. But for us taking the GED, when I say find a point, it just means those perfect crosshair points. The ones that cross. Pretty much, if this makes it clear, your grid are little mini boxes, right? Grid paper have little mini boxes. Pretty much a point is only a point for us if it hits the corner of a mini box, of a little square box. If it hits the corner, you know you've had a point. So what we need to do is find 2 points that lie on the line. Okay? So if we look at this line, where are 2 points that you can locate? This is what I mean. I see a point here, and if I continue on, I see a point right there. Those are my 2 points. Do you see that? It cannot be this one here. It cannot be this one here. It cannot be this one there. It can't be that one. It can't be that one. Do you see why? It's because they're not perfectly in the middle of your crosshairs, is what they call it. They're not hitting a corner of a box, pretty much. So those are not points. Those are our 2 points. And the thing is, potentially, depending on your line, you could find multiple points. There's a good chance that, and we'll see another example on later, but there'll probably be a point that you could click there and there, whatever, right? You probably will come at 4 or 5, whatever, and it doesn't matter how far apart or how close the points are. All I care for is you finding 2. Just plot 2 points. Who cares if there's more? Just plot 2 points. Doesn't matter where the locations are of it. Just plot 2 points, and that's your step number 1. Okay? Step number 2, my friends, is something called rise over run. So there's this thing in slope. The way the M, aka the slope, is going to be looked at is, or written as, is rise over run. Okay, rise over run. That means up and down, rise or fall. It's the same thing. And run means left or right. What we want to do is from one point, it doesn't matter which point it is, from one point, we are going to rise or fall, right? We're going to go up and down vertically till we face the other point, and then we're going to run to that point. So if I were to start on this point here, I'm going to count the steps I take to get parallel to that point. And I'm going to count those steps, and that would be my rise, okay? So if I go from this point, I'm going to go 1, 2, 3, 4, 5. All right? So far, my slope, its rise, because remember, it's written as a fraction, rise over run, is 5. That was 5, right? 1, 2, 3, 4, 5. Yep. So that, if you notice, I'm facing the other point. That was the end goal there. Now all I got to do is run to that. And it doesn't matter what direction as long as I get to that point. So I have to, in this case, go right. 1, 2, 3. 3. That's your slope. There's only one last step to find the slope, to be 100% with your slope, and that is check 2 things. We know this is our slope technically. There's only 2 things you need to check. And that 2 thing is this right here. What happened here? I apologize for this. Okay, there it goes. What you need to do is check 2 things. You need to check whether your fraction can be simplified. So that just means this: whatever fraction you get, whatever rise over run you get, always just double, triple, quadruple check that it's simplified. That just means go to your calculator, put up a fraction, and put your newly found fraction, push enter, and let the calculator determine whether it's the simplest form of that fraction, right? Because in later examples, we're going to see sometimes it could be simplified. But in this case, if you saw the calculator dished out the same answer, this is as simple as it can go. 5 over 3 will be the 100% the slope. There's only one last thing you need to check, and that's whether it's a positive or negative slope. So for that, I made my own little technique, and that's this technique, the car technique. Always draw a car from left, with the hood always facing the right. Just get familiar with drawing a car. What you're always going to do is get that car, and you're going to put it on your little line. Think of it as a hill, right? If we were to get this car, let me do this graphically so it could help you. If I were to get this, boom, and let's say I were to, is there a way to spin this? Yeah, boom, and I would have put it on my hill. Boom. Is the car going uphill or downhill? It's going uphill. That means this stays as a positive slope. So that is the answer. Positive 5 over 3, right? You must always check whether your slope is a positive or negative, and whether it's simplified. So that's my slope. You found your m. Now all you got to do is move on and find the b visually, which is super duper easy. The b, if we recall, means the y-intercept. What does that mean? All that means, my friends, is exactly what it says, y-intercept. You tell me, at what number, at what point does this line cross the y-axis? If you recall, this is the y-axis, this is the x-axis. When does this line cross or touch the y-axis? Well, if I could see here, I see that it touches it right there. What number is that? That's a 3. You could clearly see 1, 2, 3. Right? It's between 4 and 2, obviously. So just like that, you found your b. Your b is 3. You found your m and your b, my friends. It's that easy. So now comes what you're going to be doing on the worksheet. On the worksheet, you need to write out its linear equation, its final linear equation, its final y equals mx plus b slope-intercept form linear equation format, which is easy, my friend. You already have your m, you already have your b. Just put it in for m and b. This answer for this graph, when they ask you what is the linear equation of this line, is y equals positive 5 over 3x. That's a positive 3, so I put a plus 3. That's your linear equation of that line right there. Now, I did say if the GED gives you this line there and asks just for the slope, well, there's no point in finding the b, because all they want you to do is find the slope, right? So you just be doing that first initial 3 steps, and then you find that answer under your multiple choice options. If they ask for just the y-intercept, that's easy. You just look at when it crosses the y-intercept right there. You look for the multiple choice options of 3, and then you click on that answer, right? But most likely they're going to ask for the linear equation of the given line. And this is what you do here. Let's go over another example, just because you could technically stop here if those 3 steps to find your slope and to find your y-intercept was easy peasy. You could move on. You can stop here and go on to the worksheet, but there's some helpful stuff that you need to know in this next couple examples. So let's do this one here. We got to find the slope first. My end goal is to find the slope and then find the b. All right. So what's my slope? I got to find 2 points, right? There's one there, which hint, hint, hint is going to be my y-intercept. There's one there. Oh my god, I found another one here. It doesn't matter. You just want to locate 2. So I'm going to, just for fun, get the 2 farthest ones. Because again, it doesn't matter how far or how close apart they are. There's that. 2 points, done. I'm going to rise and run. I'm going to, just for fun, start on this point. And I'm going to rise, if you recall, means going up or down. And I'm going to count until I face the next point. And then I'm going to run to that point. So I'm going to go 1, 2, 3, 4, 5, 6. I'm facing another point. I know my slope temporarily, my rise is going to be 6. And I'm going to run 1, 2, 3, 4. 4. Perfect. That was step number 2. Step number 3 is just check my 2 little checkings, which means check whether your fraction can be simplified. So I just dump in the fraction. Push enter. 3, 2. It did simplify it for me. Makes sense. 6 and 4 can be simplified to 3 2s. Right? And now just check whether your slope is positive or negative. That means draw your car on your line. Always with the hood facing the right. Always with the hood of the car facing the direction of the right. And what we see here is that the car is going downhill. So that means this is a negative slope, which means I got to put a little negative here. That is my 100% slope. I found my M. B, everybody's favorite. You tell me, when does this line cross the y-axis? It crosses it at 4. My y is 4. So now just write out the final linear equation the same way you will do on the worksheet. Y equals negative 3 over 2x plus 4. Y equals mx plus b. By the way, if your y-intercept is ever a negative, you could just literally put a negative. You don't need to do plus minus 4, right? But in this case, it was a positive 4. So there's that example. Easy peasy, right? Easy peasy. You found your M and you found your B. Easy peasy. Let's go to the next example because it's a unique one. What do you do in this situation? A flat line. These ones are easy, my friends. When you see a flat horizontal line, horizontal means like this, vertically means like this. When you see a horizontal line, immediately you got to be like, I know the answer for M. It's 0. A flat horizontal line, no need to click on 2 points and then rise or run because there's no rise or run. The slope is 100% 0. Only thing you need to look for is B. When does this line touch the y-axis? In this case, at -1. So what do we do here for the final linear equation? You're not wrong if you do y equals 0x minus 1. You're not wrong. But the reason why I put this example up here is for when the GED gives you this type of question, and then on the answers you don't see this precisely, is because the GED will give it to you like this as your final answer. Oopsie. -1. Y equals -1. The GED, what they do is, if your slope comes out to 0x, what they literally do is just cancel it out. They just erase it and they leave it that. So when you see this, y equals -1, you got to be like, that's the way linear equations look when the line is flat. And then you're good. What happens when your line is vertical? Boom. These ones are a lot weirder. It does not have a slope. The slope is literally undefined. This is an undefined line. What does that mean? Well, when we get into the functions lesson, we're going to determine what makes a line and what doesn't, right? And it's called functions. But for right now, all you need to know is that when you see a vertical line, it doesn't have a slope. The slope is undefined, nor does it have a y-intercept because it never touches the y-axis, right? So how does this linear equation look like? It's very weird. Because it doesn't have a slope, because it doesn't have a y-intercept, math just says like, okay, because it needs to have a name, because it needs to be identified somehow mathematically, just tell me when it crosses the x-axis. So we know this is the x-axis. Vertical lines will always cross an x-axis for sure. So let's pretend this was 1, 2, 3, 4, 5, 6. It crossed at the -6 mark, right? So you'll just literally identify it as the x-axis, x equals -6. This is how a vertical line linear equation looks like. Extremely weird. Chances are you'll see it, chances are you won't. I don't know with that one, but the other 3 examples are the examples you want to master. So this is how you must find the M and the B of a line that's given on a graph. And this is the visual way of doing it because it's visually on a graph, right? Just make sure you go over all the examples, master all the examples, and let me know if you need any help with any sort of anomalies that popped up.